Assalamualaikum and hi, my name is Muhammad Fazli bin Zulkarnain and my matrix number is 215791. So this video is for presentation for our case study, which is for our group. Our group case study is analyzing the dynamic of a playground. Before start further, let me introduce our team member. The first one is Ashraf. The second one is Ayman Rais. The third one is Anaki Hakim. Next is me, and the last one is Ikwan. So for introduction part, basically the concept of swinging playground generally can refer to the pendulum motion or pendulum system. This relationship can generate ideas to analyze the swing playground based on the pendulum itself. From this knowledge, we can design a smooth and good swing playground according to its function while minimizing the risk and improving efficiency. Other than that, the planar motion of the swing playground refers to the motion that happens in one phase and typical to the plate. To analyze this motion, we refer to the pendulum system as I mentioned before. There are some forces acting on the swing such as tension force, gravitational force, frictional force, and so on. The next part is dimension and geometry. So from this part, we take the three general dimension and geometry for the swing playground. The first one is the length of the chain, around 3 meters common length for the playground swing, and this length is allowed to comfortable swinging motion so that it can provide a better clearance from the ground. So second is angle of release. The angles depend on the personal preference and the desired swinging motion. Around 30 degrees is a common practice from the vertical position. This angle allows the smooth swinging experience. And the last one is the position of the seat. It is usually about 0.6 meter above the ground to accommodate children, but for adults, it might be higher seat position from the children. Okay, next for the assumption, we take three assumptions. The first one is the mass of the swing we assume as the center of the mass. The second one is the chain we assume as massless, and the third one is the air resistance assumed as negligible.
Hello and Assalamualaikum. My name is Muhammad Ibn Abdul. My metric number is 215.63. And now I will present you how does the gravitational force acting on the swing affect the swing's motion. So, as we all know, the gravitational force is always acting on us whenever we sit and whenever we do something in this planet. So, as you can see in this video, the gravitational force is always acting towards the downward of the video. So, what is the value of G? M is depends on the situation actually. So the G is 9.81, but this value may be changed depends on the altitude that we are on. So the value when we are on the mountain of Kinabalu and the sea is actually may be changed. So how does this gravitational force can affect the swing motion? This force can continuously dragging it over and towards the center of the earth, which will make the mass become slower and slower. Next, the head of the swing's motion is also influenced by the force of gravity. So, the higher the swing goes, the more the force of gravity pulls it back down to the ground. So, whenever your friend pushes you too much, the swing will go higher by the gravity, but you can feel the gravity pulls you to back to the ground, which made the swing become slower. So I think that's from me. I will pass to the next presenter. Thank you.
Assalamualaikum. My name is Ahmad Ashraf bin Azhar. My metric number is 214784. I want to present about the analyze the tension force within the change, calculate the magnitudes and direction of this force various point in the swing motion. Before I start the calculation, I want to share about how I want to share step by step how to do the calculation. Firstly, we must understand the swing system. We must imagine the swing design, including the length and configuration of the change. Second, identify focus acting on the swing. We must determine the force acting the swing system, all the force. Then, third, analyze the equilibrium condition. For the equilibrium condition, we must sum all the force acting on it equal to 0. After that, four, we must apply the Newton's law of motion. Use Newton's law of motion to analyze the force, which is they have a 3 Newton of law. First Newton, second Newton, and third Newton. We use a second Newton. Newton's second law states the sum of the force acting on the object equal the mass of the object multiplied by its acceleration. So mathematically, Newton's second law of motion can be write F equal to ma, where F is the resultant unbalanced force acting on the particle and A is acceleration of the particle, and m is a mass of the particle. And then we draw the free body diagram and kinetic diagram. After we draw the free body diagram and kinetic diagram, we solve the equation, write down all the equation and solve them simultaneous to get the tension. Okay, we continue to calculate the tension on the situation 1. So first, we draw the free body diagram on that particle. We assume the tension is going up and the weight is going down. So from the particle, from that diagram, we can do the equation, which is total Fy equal to 0. Why? Because we use a Newton law. So from the Fy equal to 0, we get from the diagram, we get T minus W equal to 0. T is tension, W is weight, which is mass of the particle. We assume the particle is a person sitting on the swing. So from that we get the mass person sitting on the swing is 60 kilogram, and so we multiply with gravity 9.18, so we get 588.6 Newton. So from the situation 1, we get the tension on each change is 588.6. If we want to get the value of to change, we multiply by 2 for get the 2 tension of change. So we continue with the next situation. Next situation is when we want to swing the swing, we want to pull at some degree so we can swing. So on that situation, firstly we draw the free body diagram. On free body diagram, we assume that angle is a 30 degree. So we also assume the tension is going up and the magnitude and the weight is going down. So we apply the equation and anti direction. So and at this situation, we must do free body diagram and the kinetic diagram. So when we draw the free body diagram, we find the kinetic diagram. So from the kinetic diagram, we know we can get the equation is total Fn equal to MAN. We use the Newton's second law. How we get the equation Fn equal to MAN. So when we get this, we can get T equal to weight sine 60 degree equal to MAN. So we want to find T, tension. So we get MAN. We can get which MAN equal to velocity power of 2 equal to rho. So we can get T minus 588.6 sine 60 equal to mass 60 kilogram, and the AN is velocity power of 2. Velocity we assume we at the assumption we get the 3, so 3 power of 2 divide rho is 3, radius is 3. So we calculate, we get the tension on the situation 2 is 689.74 Newton. This value we get for the one change. If you want to both of change, we multiply by 2. So that's all. Thank you.
Hello, welcome back. So now I want to present how a resistance and friction on the swing influence the swing's behavior. So what is a resistance? As conservation of energy states that energy can neither be created or destroyed. Rather, it can only be transferred from one form to another. So this means that the force of the swing will become slower whenever any force acting on the swings. So the resistance is the frictional force that will make the swings become slower, and the friction is actually the friction on the bearing or the bar on top of the swing, on the top of the chain. So this can be reduce the friction by putting some lubricant or any to smooth the motion. So how does this resistance can influence the swing's behavior? So they actually can slow down the swing back and forth oscillation by uh, transform the force to slow down them, and then they reduce the amplitude of the swing or how far it swing back and forth. So this actually depends on the speed of the swing. So the higher the speed, the higher the amplitude. The lower the speed, the lower the amplitude. So the next one, they gradually bring the swing to a halt, which is the friction force will make the swing become static because they will push the force to zero and create the total force to zero. So the swing will become static. So I think that's all from me. I will pass to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and hi. My name is Amar Ibn Zulkifli. My metric number is 214806. Okay, for my part, I will explore how the swing motion will change with different initial release angle, length of chain, and seat position. Firstly, about different initial release angle. For different initial release angle, the motion will change when the swing is released from its starting position at certain angle, which is referred to as initial release angle. The direction in which the swing is initially moved is determined by release angle. The swing will have a higher upward trajectory and reach greater height if it released from a higher angle or near to the perpendicular to the ground. On the other hand, if the swing is released from a lower angle closer to parallel to the ground, it will move more horizontally and have less oscillation. Okay, below I have provide some example. Okay, assumption, we will neglecting air resistance and friction. Secondly, we'll treat the swing as a simple pendulum. To calculate the exact swing motion characteristic, including amplitude and period, we can use the following formulas. Amplitude equal to 180 degrees minus theta. Period, the period is 2 pi 2 pi times 2 pi times square root of L min over G. Okay, for a release angle of 30 degree, amplitude 180 degree minus 30 degree equal to 150 degree. For the period is we will get 3.09 second. For the amplitude of 180 degree minus 60 degree, we will get 120 degrees. For its period of 60 degree, we will get 3.09 seconds, same as for the 60 degree. Both swing will have different release angle. Both swing that despite having different release angle, we have the same period of approximately 3.09 seconds. However, the swing will have which release angle of 30 degree will reach a larger maximum amplitude of 150 degree, while the swing which a release angle of 60 degree will have smaller maximum amplitude of 120 degree. Next is for the length of chain. Different length of chain will give us different swing period. Different period will give us completely two different swing motion. Increasing the length of chain will result in a larger radius of swing path. Slower swing motion as it will slower the swing motion as the swing takes a longer time to complete one back and forth swing motion. Decreasing, on the other hand, decreasing the chain length will reduce the swing radius and causing a faster swing motion with a shorter period. Additionally, the swing may not reach as high during each swing due to the reduced length of arc. Okay, below is some example. Assuming we have different length of change of 2 and 4 meters, but with the same release angle of 60 degree. I will take as 60 degree. Okay, we will calculate the period with if I will explain about the period first. The period is of pendulum is like swing is the time taken to complete one full oscillation going from one extreme point to other and back. The period can be calculated using formula 2 pi times square root of L over G, where L is the length of the pendulum and G is the acceleration due to gravity, approximately 9.8 meters square. For the change length of 2 meters, we will get 4.05 seconds, and for the change length of 4 meters, we will get 5.74 seconds. The swing with a chain length of 2 meters will have period approximately 4 seconds, while the swing with chain length of 4 meters will have period of approximately 5.75 seconds. This calculation provides insight about how the swing motion characteristics such as time to complete one swing motion and the maximum angle reached during the swing. For the swing with a different change length but with the same release angle. Lastly, about the swing seat position. The swing action is also influenced by the position of the seat. Higher seat position than pivot point will raise swing center of mass and will result in a more stable swing. Higher seat position also reduces the potential energy of the swing, leading to a lower amplitude in the swing motion. However, it can increase the swing velocity and its overall speed. For the lower seat position, then pivot point will lower swing center of mass that will result in less stable swing. However, it can also result in it can also decrease the swing velocity and overall speed. Lower seat position also increase the swing potential energy, leading to a larger amplitude in the swing motion. It's crucial to keep in mind that these variables are interrelated, so changing one can have an impact on the others. So it will be impact our swing motion if we change one factor and the other factor. So it is not fit because there are so many factors that will have impact on swing motion. Okay, for instance, changing the length of chain will also change the length of pendulum of all swing, which will change the period of swing. In addition, other elements like swing weights distribution, outside force such as pushing and pulling, and friction that have also effect on how the swing moves. Okay, that's all from me. Thank you.
Hi, my name is Anaki Hakim bin Makhairi. My metron is 214882, and right now I will be going to talk about the safety consideration for the swings. So, when it comes to safety consideration for a swing, several factors should be taken into account, including the maximum allowed swing angle and the maximum tension that the chains can withstand. So, there is a maximum strain that each swing can tolerate. The manufacturer should have mentioned the maximum tension rating for the chain used in swings. The maximum load or force that the chain can withstand in a safe manner before failing or breaking is indicated by this grade. This is to avoid chain breakage, which can result in mishaps and injuries. Abide by this maximum tension restriction. Users also must make sure that the weight they put on the swing doesn't go beyond the advised amount. The maximum swing angle is influenced by a number of variables. Centripetal force should be taken into consideration first. Centripetal force pushes in the direction of the center of the swing circular part when it moves in an arc. A higher inward pull is applied to the swing as the swing angle increases due to an increase in centripetal force. So, an abnormally high centripetal force can be produced by exceeding the maximum permitted angle, often not more than 30 degrees, which can cause instability and possible tipping to the user. To define safe boundaries, it is crucial to analyze the connection between swing angle and centripetal force. Another crucial element is the swing structure layout. It must be built to withstand the dynamic loads encountered during swinging. If it is possible to determine durability and make sure the swing can sustain the forces produced at the maximum swing angle by conducting structural analysis. In conclusion, establishing a safe maximum swing angle reduces the likelihood of mishaps and offers users a secure environment. Choosing a safe tension limit for the swing chain is the second factor to take into account. The weight and motion of the swing exert tension forces on the chain as it travels. This tension force rises with the swing angle and peaks at the highest point of the swing. There is a chance of chain failure or fracture if the tension forces are too high. Therefore, setting a maximum tension limit is essential. The tension forces the swing chain is subjected to are greatly influenced by dynamic loading, such as the weight of the swing occupant. So, calculation based on dynamic analysis are necessary to provide the proper safety margin, enabling the swing chain to withstand unforeseen pressure and lowering the likelihood of accident. In the end, it's most important to guarantee user security and a satisfying swinging experience. Overall, the danger of an international accident and injuries may be greatly reduced by taking into account the maximum swing angle and creating a safe tension limit in the swing chain. Prioritizing safety and fostering a good swinging experience for all users requires careful consideration of the link between swing angle and centripetal forces, undertaking structural analysis, and taking dynamic loading into account. So lastly, we will go into our conclusion of our case study. So in conclusion, understanding a playground swing's dynamic offers important news perspective on how it moves and behaves. So we may determine significant characteristics such as the period, angular frequency, maximum angular displacement, and maximum linear displacement by taking into account variables like the release angle, chain length, and seat position, and using the principles of planar kinetics. So planar kinetics technique can be used to analyze a playground swing's dynamic in order to quantitatively comprehend and forecast its motion under various circumstances. So overall, investigating a playground swing's dynamic deepens our comprehension of how many elements affect its motion, assisting us in creating safer and more fun playground environments. So that's all from our groups. Thank you very much.